So, welcome to the Fab City Summit presentation. This presentation will be led by Mustafa Jalayel and Daniel Spooner. Mustafa is a PhD student from the University, from the Polytechnique of Montreal, from the Engineering Research School, and Daniel is a professor in the same school. Today's presentation will be focused on how the makerspaces support the development of engineering skills. The role of Fab Labs in an engineering university is to allow students to access well-maintained laboratory equipment. Polyfab is a unique fabrication laboratory at the Polytechnique Montreal because it is the only Fab Lab space for students that is managed by students themselves. So Daniel, Mustafa, the scenario is all yours. Welcome.
Thank you.
Thank you very much, Thomas. So thank you for, hi Ron, thank you for joining us at this presentation for the Polyfab Normand-Bray. I am, as said earlier, Mustafa Jalayel, a PhD student in mechanical engineering, and Daniel Spooner is a professor of professional practice at École Polytechnique of Montreal. We will start just by showing you what we're going to talk about, starting by a history of our space, how maker spaces like ours and education interacts with each other, and then the key issues that we have here at Polyfab, some success stories with graduate students and research, and then how we at Polyfab want to integrate circular economy and sustainable development. First and foremost, the Polyfab is the Fab Lab of Polytechnique Montréal. For those who don't know, Polytechnique Montreal is a French-Canadian engineering research school in Montreal, and it's renowned in the French-speaking world. The Polyfab itself was founded in 2015 by Professor Michel Dagenet and Professor Daniel Spooner, and its main goal was to build a community of people that would be passionate about innovation and technology and how they apply that in real life. It's a secret, it's a funny secret that at Polytechnique, we are mostly concentrated on theories and research and all the theoretical stuff. And here at Polyfab, we pride ourselves in hands-on applied science. So at Polyfab, anyone can be a member. It could be a student of Polytechnique, of course, but also students from other universities, other schools, and even anyone in the public in general can be a member and take advantage of our machines. Other than that, we will talk more about these two last points later, but just to be brief, selected students from the community will be hired, and then these will be allowed to train others in the use of our machines. And this team of students will be part of the management. So we are the ones who will manage, with help of a university employee and a board of members and professors. Our main pride at Polyfab is that we have well-maintained, high-quality machines that are made available to anyone with the required training. This training allows the student or the user to be autonomous and safe using the machines. And the machines that we have, well, they are FDM 3D printers, like in most Fab Labs. But we have also a new machine that we received this week, Lisa Pro SLS. Also, we have two SLA 3D printers from Form Labs, laser cutters, and a second one is even coming. And many of these machines wouldn't be really available for any individual students at the École Polytechnique because they are, all of them, minimum couple of thousands of dollars and multiple tens of thousands of dollars. So that really democratizes and really publicizes these machines for everyone to use. Where we started in 2015, where my colleague here, Professor Daniel Spooner, opened the door, he saw this space which was almost abandoned by its last occupant, and we're able to make it really clean, really safe, and really open to the public to come in and use our machines to build what they wanted. So we're really proud of where we are now. And I will let my colleague, talk to you about this part.
So the general motivation for the creation of the Fab Lab is mostly based on the fact that there was a big change in the engineering training program at Polytechnique, where around 2010, projects were integrated in every discipline every year. So all students have at least one team project or individual project per year where they do have to design. And originally it was design and write a report on it, but the idea was also having a dimension where those projects could become hands-on, where students would design, build, and test. And the spaces to permit that were not really available. We had a lot of workshops everywhere, but mostly they were dedicated to research with high-end machines, doing research projects, and that would limit the time that students actually had access to those machines. So having those capstone and cornerstone projects every year, well, the actual demand on building was a lot greater, and the actual workshops that we had didn't permit that. So the idea was trying to build a space where a community of people interested in building and testing and designing could come and use the machines themselves. And that was something that did not exist at Polytechnique. It was always workshops supervised by technicians, and the actual physical access to the machines was quite limited. So the principle was learn by doing will make better designers, but also failing in doing was part of the process, was part of the design process. So giving the opportunity to fail at a low risk and at a low cost, and learning from that and being able to iterate in the process. So from that, the idea was building really a very passionate and interested community, and where the space would bring them together. So having machines, the goal of a Fab Lab was not to have machines, but to have machines to bring people together. And that for us worked rather well, I think. So we built a maker community. These people talk between each other. They start sharing knowledge, and some of them have started companies together. So that was really the initial motivation, and we're very happy to report that it actually works. It probably can work better, and we're still iterating on how we can make that better. So having access to this permits better innovation because people are more willing to try things. So we believe we have a really vibrant community interested in problem solving, and a mix of very different expertise. So Mustafa will show you the different students and different people that we do have, and we'll report on actual startups that we've had. So I'll let Mustafa continue presenting. Oh no, one last slide. So we do have the formal training where we do have project courses, but there's also an independent community of competition teams that has been forever at Polytechnique. So there's a very independent culture where student groups create a team to compete with other universities in very specific projects. So we have about 18 at Polytechnique, and they have an independent support. So they have an external out-of-campus space that's about, I think, 12,000 meters, or it's huge. And every team has their specific space where there are tools, where they can build. But the addition of a Fab Lab was to give higher technology tooling and machines to build themselves instead of outsourcing a lot, build themselves and iterate themselves their project. And that seems to work because most of our, let's say, our highest experienced members comes from these competition teams. So I'll let Mustafa continue.
The way we make all of this work is, well, first and foremost, like we already said, is to build an open and learning by problem solving community. And this is what we had. This builds the core of the Polyfab, and then we were able to build on this. And to do so, we had to make operations as good as possible. We had to involve stakeholders So students, professors, technicians at Polytechnic, and everyone who would be involved in this space to be involved in the process definition. What we are, what do we do, and how do we do that? So they were also involved in the decisions. And of course, because we are in a space where machines are working, where a milling machine might be cutting some steel, and then a laser engraver might be engraving some wood on the other side of the room. Safety and security was to be the most important priority. And because we had that as the first priority from the beginning, we were able to win school and regional prizes in first place because we were really good with that. And then we had to make sure that everyone that comes in wants to use a machine, a 3D printer, for example, we had to train them, show them how to use the machine reliably and autonomously, because we don't want to handhold the student. We want them to really learn what they're doing. And for that, the basis of our tutorial system is YouTube. We have a channel on YouTube which has, I think, now 140,000 watched views that are dedicated to showing what to do with the machine, how to change material for a 3D printer, how to clean the lens for the laser engraver, or how to mill a part that you want on the tarmac. And for that, YouTube was really great. And then when we had that, we saw that students would come in and do what they want. And we really want to involve them in how to build and manage the space. Well, it's for them at the end, it's not for anyone else. So we take feedback, we change the space, and we iterate. The way you saw the pictures before, how we were in 2015 versus now, well, we were really different in 2018. In 2020, we changed a lot because every time we see, hey, that could be improved, or we get new machines because students ask them. So we always iterate, always continuously improve. And to speak little bit more about the community, the core of our community is by the student animator team. So we are staff members. I am part of this team. That's how I was really engaged with the Polyfab. So as I said earlier, some selected students from the community will be selected and trained, and we become the on-site resources and the person responsible for the activities inside of the Polyfab in our shift. So we train people, we make sure that they know what they're doing, and we also go out of our way to know what the students are doing, the users are doing, and try to learn from them. And if we can, teach them something they didn't know. For example, if we see someone trying to 3D print something that would be much more easier to do with the laser cutter or the milling machine, we try to show them, try to teach them how to select the best process for their machine, for their product. And because the student animator team is from any engineering field, there's no preference at all. We have a lot of mechanical engineering because, well, it's the easiest connection. But there's also aerospace engineering, biomedical engineering, civil engineering, and also software engineering that make their way at Polyfab. And also we have many grades from students from undergraduate or graduate students. So there's a lot of teaching and learning to be, there's a lot of teaching and learning to happen intersectionally at Polyfab. And until now, we've spoken about mostly schoolwork or student club stuff, but it's not just that. Anyone can do any work at Polyfab. For example, we are associated with the Entrepreneurial Support Office at Polytechnique, where startup can begin to form. And these startups are then directed to our space to prototype, to build their first product. And because we are a free workspace, they can use, and they just pay their membership and the material they use. And it's really easy to iterate, to build something new if you don't have a high cost to entry in the field. As I said, there's no preference on type of work. And if you could just go back one slide again.
Sorry.
That's okay. There's no preference on type of work, and we really want the people yes, to build startups and do their integrated projects or whatever, but we mostly want people to learn how to use the machine. So any project is worth the experience you get from using the technology. If you want to build a rocket, you can do it. If you want to build some new startup that would revolutionize a sector of the industry, do it. If you want to just print a Pokemon to put it in your bedroom, do it. It's worth the experience you get, and that's what Polyfab is really here for. So we were speaking about startups and how they can develop in our space. Well, here are some examples of startups that began at Polyfab, or at least passed through Polyfab when they were prototyping. Paretu is a group that developed a safer and cheaper intubation process for COVID-19. So last summer, they were here at Polyfab while the crisis was really strong. They were trying to develop something that would be easy to give to the doctors and anyone that nurses and anyone that would have to intube someone to help them live. They were here working and designing stuff. Statera Medical is a startup that is right now at Polyfab, not today, but right now at Polyfab, designing a shoulder prostheses. They recently won a grant at Polytechnique to help them develop something new and start up their company. Crisa Lab is one of the original startups at Polyfab. They built a portable and accurate real-time soil data solution, and they are really one of the original people that came at Polyfab and make use of our machines. And then we have Enthalpie and Xpedals, who are both people who passed through Polyfab when they needed to prototype something, when they needed to print or laser cut or whatever, and they were able to do that without a huge cost to entry in their field. So because the Fab Lab charter is we hold the Fab Lab charter as true document, all work is possible in our Fab Lab, in our space, and all work is owned by the individual or the company. Now we were talking about startups. Let's talk about the student clubs and what they do that are really nice for the Polyfab. First one, the one we want to talk about is Oranos. It's a student club dedicated to design, build, and test rockets. They're a really good student club that wins in the top 5 in the Spaceport America Cup that is held in July, I think, every year. To win every time, they have to iterate. They have to iterate on rocket engines, avionics, and structure. So every time they want to iterate on something new, they require various types of parts, and they use different machines. And one of the innovations they try to do at Polyfab that they are still developing is the exhaust, the outlet of the rocket. They have to have a specific shape to optimize the harvesting of the energy that happens. And every time they change that shape, they have to pay an outside company, either ask for sponsorship, and it's really costly and long design process. But because here we have the SLA Form 2 and Form 3 3D printer, they were able to use the high temperature resistant resin and try to model what they want to do. Here they had to heat treat it and treat it with other chemicals to make sure that it would be able to resist to direct flame. And they see here that yes, it is able to resist to high temperature and to direct flame. And they are able to use it for testing of the optimal shape that they need. And because they did that at Polyfab, and we were the middleman between them and Formlab, the company of the 3D printer, we were able to keep all of this information. And next time someone asks us, hey, do you know something that would resist direct flame for a couple of minutes? We are able to refer to that experiment that Oranos did and spread that knowledge more efficiently. So when we talk about research, it's not only student clubs that do some experiments, it's also graduate students like myself and research associates. It's a funny thing that sometimes the researchers or the graduate students really lack hands-on experience with machines. Often they work in the theory and the simulation space, but they don't. It's not a given that they will know what to do with a machine. Also, like we said earlier, university labs will buy expensive machines and high-end machines, but they will restrict their use to their own students in a locked laboratory somewhere where normal students will not be able to use it. So now we try to do a new project where professors can pool resources together and buy an expensive machine and put it at Polyfab, where they take advantage of the fact that we at Polyfab will maintain it and make sure that it works well for most students, for all students. And they have the advantage of having that machine, paying a fraction of it, and letting their students use it.
And the training that comes with it will is supported by Polyfab. So that sort of makes it easier for the professors.
Yeah, of course. One example of a doctorate student who was able to take advantage of our free accessible machine is Batu Sayer, who is a doctorate student in biomedical engineering. She designed a wireless dynamometer for the pelvic floor, and because the parts change constantly, and because, well, it's biomedical environment, she had to change the shape multiple times. And because our printers are free to use and you don't have to require funding or anything else, she was able to iterate around 20 times inside of 1 month, which she couldn't have done that easily outside of the Polyfab. Another student who is a staff member of Polyfab is Fakundo Sosarei, who is a doctorate student in mechanical engineering. His research is about recycling material, and he wanted to to produce a machine for Polyfab about recycling failed print material, so failed filament for 3D printing. It is known in the community that re-extruding failed print to a filament is really hard and non-constant and not reliable. So his project was to build press injection molding that would build either blocks to machine in a CNC mill, or even if you produced a mold, you could inject it directly into that and have your part that you want exactly. And the machine, hopefully, it will be for Polyfab, and we will be able to use it and recycle failed print materials, which builds a circular economy, and we're able to reuse the material. So talking about circular economy, we want to allow easy access to tools for people to repair their own objects. That's one part of the reason why Polyfab is open to everyone. Because we know that the information about how to repair an object is easily accessible on the internet, but sometimes tools are harder to come by. There is also a once per year event, which is Repair Café. It's a group of volunteers that offer to help to repair machines and objects, and in collaboration with the person who brings in the machine. So that way, next time, maybe they will be able to repair it themselves. Thank you for listening to us. If you have any questions, you can find our website on the chat just now. And also you can go to polyfab.polymtl.ca or just look for Polyfab on Google. Thank you very much.
Thank you. I believe, Thomas, we're finished.
Yep. Thank you, Mustafa and Daniel. It was a very, very interesting presentation. And I have a question, actually.
Yep.
Because at the same time, I run a Fab Lab. I have the chance to direct 2 Fab Labs in my university back in Chile. One is located in the Faculty of Architecture and Design and Urban Studies. And the other one is the southernmost Fab Lab in the world that is located in Puerto Williams. That is a Fab Lab with an orientation to the community. And I really like this idea, what you are proposing or what you are doing actually, about, let's say, giving the power to the users somehow, right? So how do you see that maybe for the Fab Labs, they are not within the ecosystem of a university? Those Fab Labs can be also administrated somehow by the extended communities. Can you see that your way of what you have achieved until now can be somehow exported? And if is that it seems that also exported in the way that other labs that are not in a university, as I mentioned, can can do more or less the same methodology? And if is, and then what changes you might suggest to those labs that might be interesting of given the administration power, let's say administration in the wider view, right? To the local or to the Fab Lab community.
If I can start on this, when we started the Fab Lab, our goal was to be part of the Fab Lab charter, and that actually helped us to convince our school that having our Fab Lab open to all, giving us access to the Fab Lab community, would be a good thing. So it wasn't easy because just for insurance purposes and everything else, there was a lot of resistance. But what we did to reduce that resistance was to build a very, very robust training and safety and security system that actually is sort of becoming a reference in our school and a reference in our local Fab Labs. Let's say we have some kind of expertise now that we try to share locally, that I think has value for everyone. And it's an open Fab Lab, so anybody can contact us, and we're ready to share and give pretty much everything that we've done. Everything is open source. Everything, all the YouTube videos are accessible to all, even non-members. So at a certain time, we had more views from people in Tunisia and North Africa than local views. So that, that was great for us. We were really happy, and that was one of the goals that we hoped we could achieve, because in the French community, Fab Labs, the actual documentation is not at all at the same level as the English community, and probably the Spanish one either. I'm not familiar with the Spanish one, but so we wanted to be some kind of a reference where we could build and share in the French community training and different. I don't know if I've answered the question correctly.
If I can add something to that, how it could be exported or added to a Fab Lab that is not in a university setting. Well, I think the most important part is the core of the Fab Lab. If there is at least one or two people that are fully giving their full time to their Fab Lab, and then they are able to get some other people to fill in the gaps, that's what builds the basis of really functional Fab Lab and open source Fab Lab. Because it's not only, I know some Fab Labs that are for profit and are like they sell time on their machine, but that's not really a community. That's just an open shop. And I think really, if you include a core of users that are integrated inside of the management, that's how you're able to open it and really make it for the users and by the users.
Yeah, our business model is quite particular to a university context. So taking it out, and if we look historically, the success of Fab Lab networks, private Fab Lab networks, have been so-so. I think there was a lot of experiences, very large scale in the US, private Fab Labs, and a lot of them went under, just went bankrupt. So we really tried to be as economic as we could and build from there, and not the reverse. So when we buy machines, it's really been thought out, and we know that it will be used. And sometimes we do, like the SLS machine, it's sort of experimental. We're saying, okay, we'll invest and we'll see what happens. But mostly we try to do as much as we can with as little money as we can. That's really part of the challenge, I think.
Yeah, thank you very much. Yeah, you somehow answered the question. Because the challenge that you are addressing is to change this mindset that a Fab Lab is a space with machines, right? That ends up in the machine. You are changing like the way of seeing the Fab Lab from machines to projects with the capstones and milestones projects, right? And involving the whole university ecosystem. So yeah. Daniel, Mustafa, again, thank you very much. As I mentioned, this presentation is being recorded and will be disseminated in different platforms of the Fab City community. So have a great weekend, and thank you very much.
Thank you. And again,